Hello, this is Joe Neville and welcome to BGP Route Reflectors and Network Design. This is video 8 in my BGP In-Depth playlist. Coming up in this video, we're going to be talking about route reflectors, but first I want to widen the scope and talk about the network concepts of control and data plane. If you want to understand advanced networking, you really need to get your head around these concepts. And route reflectors help illustrate these concepts and how they influence network hardware and network design. We're then going to be running through a demo using HPE Aruba kit, and we'll be looking at inline route reflector network design versus centralized route reflector design. And finally, I'll be finishing off by showing how this links to software-defined networking. But first, a note about kit. If you've watched any of my other videos in this playlist, you'll know that I have been using the HPE Comware 7 Virtual Services Router, the VSR, for all of my network demos. But recently, I've had a visit from the Switch Fairy and took a delivery of some new lab kit. I've got 3 Aruba 3810Ms, which I'm using for my layer 3 devices. They run OSPF and BGP, and I've got an Aruba 2930F, which I'm using for my layer 2 functionality. So obviously that's quite a change because I'm using a different operating system, but the general concepts of BGP and the configuration is very similar to other vendors. This video is really continuing the trend of looking at BGP concepts rather than delving into an in-depth view of BGP on Aruba OS, but I am going to do that in a future video. Okay, what is a control plane? The control plane is a concept in networking that's concerned with building a view of the network and signaling the network topology information. So in hardware, this is the part of the networking device architecture that deals with the signaling, with building this view, and so that manifests itself as the part of the architecture that runs the routing table. And if we apply that to networks, that's the function of the network that handles the signaling, so the routing protocol updates, rather than the customer traffic. What is the data plane? That's also known as the forwarding plane, which is pretty self-explanatory. That's the part of the network and the hardware that's concerned with the customer traffic and pushing packets. So it's how to process and forward packets as fast as possible. In hardware, that's the switch ports and the switch fabric. And when we apply this concept to the network, we're talking about the path of the customer traffic, of the application traffic. So this separation of concept is useful because they create different areas of interest in our network and parts of the router architecture. So devices that are primarily concerned about the control plane, so they would have a large routing table, that would tend to be a layer 3 device like a router. And in general, routers tend to have slower speed ports than devices that are more concerned with the data plane. So that would be about pushing packets as fast as possible. A data plane focused architecture would be your layer 2 switches, so your 100 gig switches nowadays that might not even have layer 3 functionality on them. They're all about pushing the traffic around the network as fast as possible. So what's all this got to do with route reflectors? Well, route reflector design helps to illustrate in the network the difference between a control plane and a data plane. Let's look at a route reflector network design, that being the inline route reflector. So here's my network. I've got 3 Aruba 3810Ms. They've each got a loop back, so that's 1111, 2222, and 3333. And this one here, -3, that's the route reflector. I'm running OSPF and BGP. And in this network, I have the 3810M-2, that's injecting a BGP prefix. And our traffic flow is from left to right towards this prefix. In this design, the route reflector sits in both the control plane and the data plane. Here you can see if we're going from left to right, then the traffic will flow, so the data plane will flow through -3. It will go 1 up to 3 and then down to 2. So that will follow the path that our network signaling, our iBGP, will take to get to the destination. But remember those iBGP rules. By default for internal BGP, the next hop attribute is not changed when the update is forwarded onto a neighbor. So the next hop towards our prefix, our 10.150.99.1/32, the next hop of 2222 will be unchanged by the route reflector when it is advertised down to 1111. And here you can see the control and the data plane flowing through our route reflector. Let's look closer at this by logging into our hardware then. Here I have SSH sessions to my 3 Aruba 3810Ms, 1, 2 and 3. Remember, -3 is the route reflector. Here's an example of the BGP configuration on one of the clients. And here's the configuration on the route reflector. There you can see the specific commands to make the neighbor 1111 and 2222 the route reflector client. And I've also configured a cluster ID of the loopback of the -3. So as I mentioned, -2 is injecting this 10.150.99.1/32 prefix. There you can see that command. Let's have a look at the BGP routing table. Pretty standard stuff. There you can see the prefix being injected. Now let's have a look at that on the route reflector. There's our prefix, and we can see the next hop of 2222. Then finally, let's have a look at that on -1. There's the prefix, and as you can see, the next hop is not changed, so it remains as 2222. And because the next hop is not changed, that allows us to utilize route reflectors in a different way from inline, and that is the centralized route reflector. Here's an example of a network design which utilizes a centralized route reflector. Here you can see what I've added is I've added a physical link here between -1 and -2, and I'm running OSPF across there so that they know about each other's loopbacks, but I'm not running iBGP. So the iBGP control plane runs from -1 to -3 and -2 to -3, but not between 1 and 2. And the centralized route reflector, in this case, participates in the control plane only. Remember, the next hop is not changed, so the customer traffic, the data plane, can flow from 1111 to 2222 directly, and thus the data plane does not flow through the route reflector. Let's go back to our hardware to illustrate this point. Now at the moment, the devices are still configured for the inline route reflector, and what I'm going to do is I'm going to transition it to the centralized route reflector. Now in the inline model, remember the route reflector sits in the control and the data plane, so from -1 our next hop towards our destination prefix is 2222. But the next hop for 2222 is this 10.150.11.2, and that is the route reflector. So to turn this into a centralized route reflector design, we turn on OSPF across this link here, and that is VLAN 10. I've already configured the device for OSPF, and I had VLAN 10 on -1 layer 3 functionality disabled. So what I'm doing is I'm just enabling that with this command, no disabled layer 3. Checking the OSPF adjacency tables, we can see that -1 knows about 2222 and 3333, so our OSPF is now up. So this has now transitioned into a centralized route reflector design. The BGP is not going to have changed at all. The next hop is still going to be 2222. There we are. So we can say that the control plane hasn't changed at all in these different network designs. But the route to the next hop has changed. So now we know about 2222, so the next hop to get to our destination prefix is now across the VLAN 10, and it is 10.150.10.2. So that is the interface here on the Aruba 3810M-2. And that means in our network the control runs from 1 to 3 and 3 to 2. Customer traffic flows across this 1 to 2 VLAN 10. And what we can say is the control plane is here and the data plane runs across here, across VLAN 10. In this case, it means that the route reflector is obviously a lot more interested in the control plane rather than switching packets, rather than the data plane. And that allows specialized hardware. So for route reflectors, we can use devices that are concerned about the routing table. So more like routers with lots of CPU and lots of memory to hold large routing tables, rather than devices with high-speed ports. So on our route reflector here, if we were using an inline route reflector, we would want to get the traffic through the network as fast as possible. We're going to want some 40 or 100 gig interfaces. But if we design the network like this for a centralized route reflector design, then we just need something that's got a lot of CPU that can handle a large routing table, but can have relatively slow ports by today's standard. We don't need 100 gig ports on our route reflector because it's not handling the customer data. That has important implications when you're thinking about your network design and what devices you can use in your data plane and what devices you can use for your route reflector. And there are even cases of network designs where the route reflector can just be a virtual router, such as the HPE VSR running on a server, rather than dedicated networking equipment. Okay, so to finish off, what have route reflectors and SDN got in common? Well, if you think about what we're doing with the centralized route reflectors, what we're doing is creating this centralized view of the network that's really interested in the control and the signaling. It's working at the software level rather than the packet pushing level. And that's really a key element in the approaches of SDN. In this model, if you swap out the idea of the centralized route reflector and install an SDN controller like Open Daylight into your thought process, then I think it makes a bit more sense. With an SDN controller, you can get a view of the network and manipulate the forwarding plane from a centralized point. And I don't think it's too much of a leap to say, well, that's the kind of thing that you're actually doing and have been doing for years with BGP route reflectors. And whether you agree or disagree, if you think that's too much of a leap, the point is, I hope I've expressed how just understanding the concepts of the control plane and the data plane and applying these to network and network design and the way that you think about networks can be of real benefit. Okay, that's it for this video. Please do like, comment and subscribe if you enjoyed this video. Lots more BGP and IP routing videos coming up, and I will specifically be looking at BGP on Aruba OS in future videos. But that's all for now. My name's Joe Neville. Thanks for watching and goodbye.